Chapter 4 is going to be kind of like an introduction to trigonometry. So we're going to start with talking about angles and different ways that you can measure an angle. Number 1 says an angle is in standard position if its vertex is the origin and its initial side lies on the positive x-axis. Okay, so if I have an angle, let's say this is my initial side, positive x-axis. This is my terminal side. The terminal side is always will be either in one of our quadrants or it can be on one of the axes. Okay, but I'm going to call the angle theta, and that'll pretty much be the symbol we use most of the time when we're talking about angles. So we say that this angle is in standard position because its initial side is the positive x-axis, and the vertex of this angle is the origin, 0, 0. Now we can have angles that have a positive measure, which this one would, because its terminal side being in the first quadrant. If our rotation is counterclockwise, then we're going to have a positive angle. You can have rotation that is clockwise, and that's going to result in a negative angle. So I could have an angle here. Say this is the initial side, this is my terminal side, and if I want to rotate in the clockwise direction, this angle would be a negative angle. Okay, and then again, if we have an angle whose terminal side is on one of our axes, that's called a quadrantal angle. Okay, so you may hear some of this terminology throughout the chapter. Now there's two ways that we can measure angles. So under part 2, we can measure angles in degrees, which is commonly what we're used to, or we can measure angles in radians, okay, which is usually kind of the new part of this section that we're going to talk about. If we're going to measure in degrees, let's look at an axis. This would be 0 degrees at the positive x-axis. This would be 90 degrees, 180 degrees, 270 degrees, and then a final rotation back to 0 would also result in a 360 degree angle. So we know that one full rotation is 360 degrees. And now remember, we can have angles that are acute, which means they're going to be between 0 and 90 degrees. Obtuse will be greater than 90 but less than 180. A right angle would be a 90 degree angle, and then a straight angle would be one that's 180 degrees. What we're going to talk about next is how this is related to what's called radian measure. Okay, so under part 3, I've given you a definition that says the radian measure of any central angle is the length of the intercepted arc S divided by the circle's radius. Okay, so let's say if we have a circle, I'm just going to kind of sketch it on the axes that we have here. Okay, let's say this is my circle, and I have an angle that I will call theta. That angle is a central angle because its vertex is the origin, and that angle intercepts an arc or a portion of this circle. That arc length is going to be named S. Okay, from here on out, when you think about arc length, it's going to be usually the variable S. And so then the radius of this circle would be the distance from the center to the circle. So this would be my radius here or here, either one would be the same. So the radian measure, it says, of this angle would be the length of S divided by the length of R. So this is a formula that we'll use in different forms later on. Theta equals S over R. Okay, this angle measure, this theta measure is in radians whenever you use this formula. Okay, this will give you the radian measure of a central angle. 1 radian, if you look at the last definition here, 1 radian, we say this is the measure of a central angle of a circle that intercepts an arc equal in length to the radius of the circle. Okay, so back up here in my diagram, if S were the same length as R, when these are equal, then we say we have an amount that's equivalent to 1 radian.